Good morning, all. I am V. Prasannanjaneya Reddy, working as Assistant Professor in the Department of ECE, IARE, Dundigal, Hyderabad. In this session, we are going to discuss about communication interfaces, introduction, and some few devices which provides the communication. So, communication interfaces. Communication means sharing the information from one point to another point, or one to many. So based on different parameters, we are classifying the communication into different types. One is way of communication, one of the parameter. So in that point of view, way of communication point of view, first type is simplex. Simplex means the information sharing from transmitter to receiver only. One way communication. Example, pager. Next, half duplex communication. Here, the information is transmitting from transmitter to receiver as well as receiver to transmitter. But at the same time, at a particular point of time, information is shared in the one direction only. That is called unidirectional communication. Either transmitter to receiver or receiver to transmitter. Example for this communication is walkie-talkie. Again, to provide the communication at the same time, they are designing the full duplex communication. In this type of communication, at the same time, the transmitter send the information to the receiver as well as receiver to the transmitter. Example, mobile phones. Okay. So based on the way of communication, either one direction in particular time or both directions, like that. Based on that, the communication is classified into either simplex, half duplex or full duplex. Simplex means the information is transmitting from source to destination or transmitter to receiver only. Example, pager. In half duplex, at a particular point of time, the sender send the information from the transmitter to receiver only or receiver to transmitter only. Example, walkie-talkie. Similarly, to overcome that limitation, because at only one direction, that is unidirectional communication. To provide the bidirectional communication, they are designing full duplex type of communications. At the same time, I can talk with you students talk with me. Example, mobile phones. Okay. Next, how many bits is transmitting in the unit amount of time? Okay. Based on that, communications are classified into two types. One is serial communication. In serial communication, only one bit is transmitting at a time. So, one bit per unit amount of time, unit time. So, what is the advantage of this type of communication? Only one communication line is required. So, the cost of the communication equipment is less. That is the advantage, low cost communication. Only one communication wire is sufficient. Mostly in our daily life, we are using serial communications. Sometimes, if you want to improve the speed, improving the speed means in unit time you are sending more than one bit. For that, they are designing parallel communication. Like 8 bits or 16 bits or 32 bits and so on. That is depends on the bus width per unit time. Okay. So, in the beginning days, they are designing serial communication. In that, one bit only transmitting in unit amount of time or at a particular point of time. The advantage is we require only one wire to share one bit information. So, low cost. So, the cost of the communication is less or low cost communication. But speed is less because at a time we are sending only one bit. To improve the speed or to send the more than one bits at a time, we are using parallel communication. Here we are sending 8 bit or 16 bit or 32 bits and so on in the unit amount of time. Example, printer. Okay. So, advantage is it is more speed since it transmitting more than one bit at a time and comparing with serial communication. Limitation is cost is more since it requires 8 wires or 16 wires or 16 lines data, 16 data lines or 8 data lines or 32 data lines. That depends on the bus width we are providing here. So, automatically the speed will be improved. Okay, it is high cost, whereas serial communication is low cost. Okay, these are the some types of communications. Again, so coming to the communication point, peripherals point of view, if you are providing the communication within the printed circuit board, that is called on-board communication. One more parameter is where we are providing the communication. On-board. On-board means within the printed circuit board if you are providing communication. That type of communication peripherals called onboard communication peripherals. Okay. Examples for onboard communication peripherals are: first one, inter-integrated circuit. Inter means in between the elements of the embedded system. If you look at the embedded system, that contains various elements, core components for executing the instructions, memory devices for storing the instructions, input devices for capturing the current information, output devices for monitoring and controlling the peripherals, additional hardware for doing special functions. So the information needs to be transmitted from input devices to core components to memory devices to core components to special hardware, or core components to output devices. So the information needs to be shared among various peripherals based on requirements. Okay. Oh. So in that point of view, one of the communication peripheral is I2C. In between, I2C means inter means in between. Inter-integrated circuit. Next one is serial peripheral interface. Next, UART, Universal Asynchronous Receiver and Transmitter. Next, one wire communication. These are the examples for onboard communication interfaces. Next, if you want to provide communication from PCB to external peripherals, at that time we require off-board communication interfaces. Off-board communication interfaces means which share the information from printed circuit board to external peripherals, like mobile phone to laptop, or mobile phone to desktop, or our TV remote to TV desktop, TV monitor screen, remote to screen, like that. That again classified into serial and parallel communication. Serial, parallel. Serial communication means the device transmits one bit at a time. Again, in that, these serial communication peripherals are classified into wired communication, wireless communication. Wireless communication peripherals. So through wire we are sharing the information. Again, under this, first one is recommended standard 232 communication. C is the version. Okay, RS232 cable, or 484 or 485. Next, universal serial bus, Ethernet. Next, IEEE 802.11 or CAN cable, control area network, local interconnect, media oriented system transport, or Flickr. These are some of the wired communication peripherals which are used in the embedded system design for sharing the information among various peripherals. Next, coming to the wireless communication peripherals. In the beginning days, we are using infrared communication in the TV remotes. Next, we are using Bluetooth. Next, Wi-Fi. Next, Zigbee. Next, GPRS. Next, radio frequency waves. Okay. So these are the different types of communication peripherals. We may use any one or few based on our requirement. Sometimes these peripherals are available within the core component. If you look at the 8051 microcontroller, within the 8051 microcontroller itself, it contains 8-bit UART. Like that. In some of the communication TM4C123 GH6PM, it contains onboard within the chip. Within the chip, it contains I2C, UART, or that communication peripherals. Sometimes these peripherals are available within the chip, within the core component. Okay, based on requirement, we may use any one of them. Now we are going to discuss about I2C, Inter-Integrated Circuit Communication Protocol. I2C. So I2C means Inter-Integrated Circuit. It is a synchronous means the transmitter and receiving have same clock frequency or same baud rates. Okay, that is synchronous. Synchronous, half duplex, two-wired, it contains two wires, serial clock line, serial data line. Two-wired serial communication bus. Okay. I2C protocol is a synchronous, half duplex, two-wired serial communication bus. In the 1982, Philips designed this I2C protocol in the television handset motherboards, PCB boards. In televisions, PCB boards, for sharing the information among various peripherals in that Philips TV. They are designing this I2C protocol. It is somewhat low speed communication protocol, but it is low cost peripheral. The cost of this device is low when comparing with other ones. Okay. Here I am taking the processing element and different types of slave devices. If you look at this one, whenever serial clock is high, suppose it is 0, this value is 1. Okay, serial clock is high, serial data is low, 0. That indicating the frame is started, start of the communication. Okay, suppose this is master, this is slave. Whenever master wants to do some operations, so before going to the sharing of communication, look at the frame format. If you look at the communication frame format, It contains start of the frame, that value is 0. Next, it contains 7-bit or 10-bit destination device address. Each device contains particular address. So, the device address is defined in the 8-bit ID or 10-bit ID. Next, it will take next bit is indicating type of operation. Either device wants to read the data or send the data, receive the data or transmit the data, or read the data or write the data. So that is that bit. Next, acknowledgement bit. Next, 8-bit data. So the information, the first 8 bits, next 8 bits, next 8 bits are lower 8 bits, next higher bits, 0 to 7, 8 to 15, 16 to 31, 16 to 23, 24 to 31, like that. So 8-bit data. Next, corresponding acknowledgement bits until it will share. At the transmission is completed, it will send stop bit. Okay. So if you look at this communication, I am considering master slave. Whenever master wants to, or master or CPU, let us consider CPU, or this is memory device. Let us consider. Whenever CPU wants to retrieve the data from memory device, it send read request. I want to read the data from memory device. First, it will send 0 bit, that indicating start of the frame. Next, it will send 7-bit address, something, some 7 bits, 7-bit address. Next, it send read bit. Actually, read is 1. That information is passing to from master to slave. So this indicating read operation. Then, if the memory device is able to send the data, at that time it will send acknowledgement bit, that is 1. Again, it will send the 8-bit data, whatever the content. It will send 8-bit data. After receiving the data properly, the master or CPU sends acknowledgement. Like that, until it wants to communicate, will communicate and do the operations. After completion of operation, the serial data line is 1. SDA, serial data line is 1. Like that, the I2C device sharing the information from CPU to the memory or core component 8051 to the its memory device. Whatever the core component we can take. In the same manner, if you want to write the data, first CPU, this is memory. So after performing the operation, CPU wants to store the result. At that time, it will send request. I want to write the data. For that, start of the frame 0. 0 indicates start of the frame. Next, to which memory device? Because in the device, so many memory elements are there. RAM is there, ROM is there, cache memory is there. So different types of memory devices are available. So among which device it wants to share, in which memory device it wants to store the result, that will be defined the 7-bit address. Some 7 bits. And since it wants to write the data, that value is 0. It will send 0. After getting the request to the memory device sends acknowledgement. Okay, I am ready to accept the data. Okay. Then CPU sends 8-bit data. After receiving the data, memory device sends acknowledgement. Okay, I received the data properly, like that. it will send acknowledgement bit, that is 1. If it is receiving properly. If it is not receiving means it will send 0, negative acknowledgement. So like this, the CPU store the result in the memory device by using inter-integrated circuit communication device. After completion of operation, CPU sends stop of the frame, that is value is 1. Okay. Like this, I2C device sharing the information from CPU to memory devices. Here, there are different types of I2C devices are there based on the baud rates. First one is standard I2C. That baud rate is 100 kbps. Next, fast I2C, that is 400 kbps. Next, fast plus, that provides 1 mbps baud rate. Next, super fast, that is 3.4 mbps. Next, 5 mbps. So like that, I2C device, there are various provides with I2C devices are available with different baud rates. Okay. Next, serial peripheral interface. So, serial peripheral interface is a synchronous full duplex forward serial communication bus. 4 wires, serial clock line, serial data input, serial data output, chip select. Okay, these are the 4 lines. Okay, SPI, serial peripheral interface is a synchronous full duplex 4-wired serial communication bus. Synchronous means both master and slave, or source and destination, or transmitter or receiver having same set of parameters like same baud rate, same data length, or same clock frequency, or same number of parity bits, like that. Number of start bits, number of stop bits, number of parity bits, like that. Okay. Here, full duplex means at the same time CPU send the information to the memory devices and the memory devices send the data to the CPU. At the same time, the SPI device share the information from master to slave and slave to master. Okay. 4-wire means it contains serial clock line, master output, slave input, master input, slave output, slave select. Here slave means to which device to wants to interact. To which device I want to share the information. Okay. That is 4. So it works on the principle of shift registers. Shift registers. So suppose the CPU wants to store the result in the memory device. Let us consider. At that time, the CPU send the data to the shift register available in the CPU. Like this is CPU, this is memory I am considering. At that time, whatever the data it wants to store, the data is stored in the register, 8-bit register. Then this sends, so serial clock is high, initially serial clock needs to be high, and select the particular slave device. So based on the this memory device address, that slave is selected here. Select the device which it wants to store the result. So by using slave select, we can select particular device. Here memory or ADC or some other device. Watchdog timer. So I want to store the result. So the CPU is interfacing with the memory device through slave select. Next, the serial clock needs to be high from 0 to 1. Next, whatever the data in the shift register, that is shifted to the master output slave input. Master output slave input. So from this, it will send the data to the memory device. Okay. At the same time, suppose memory wants to share the information to the CPU. It contains also shift register. Whatever the content it wants to share, that will be shifted to the shift register, that is to the CPU. So through master input, slave output. Master input, slave output. Okay. Like this serial peripheral interface share the information among various peripherals like CPU and memory devices by using shift register principle at the same time. Next, UART, Universal Asynchronous Receiver and Transmitter. Okay, here it contains transmitting data, receiving data. Before it wants to share the device wants to share the information, it set the common settings like baud rate. Baud rate. What is the baud rate of this baud rate? Number of start bits, stop bits, parity bits, number of parity bits. So this we need to set the parameters. These parameters should be same to the transmitting device or master or CPU and memory. Let us consider. Or this is 8051 and this is some memory device. So first set the identical settings to the both devices. Both should be having same baud rate 9600 bits per second or 3600 bits per second or 11200 bits per second, like that. Both transmitter and receiver should have the same baud rate. Next, start bit. So it contains one start bit, one stop bit and parity bits. So whenever it wants to transmit the data from transmitter to receiver, it will send the data. Once these are setting the identical settings for both transmitter and receiver, the information transmitting from transmitter to receiver and receiver to transmitter. Okay. Like this, UART, Universal Asynchronous Receiver and Transmitter, share the information among these two devices. So each time we need to set identical settings. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.